Alright, so we're just going to take a quick look at function notation. So if you have a quick squiz at this meme here, we've got f of x is really just y. So that is one of the major points. F of x is just what we would usually write as y. So we're going to familiarize ourselves with the terminology and notation around functions, and we're going to determine the values of functions at certain values of x. So notation f of x, which is what we call it, means that f is the function that converts x into the y coordinate. So a function is like taking an input and giving us an output. So the function f, such that x is converted into 2x plus 3, is basically what the function is saying. Reading through this, we've got our function f of x equals 2x plus 3. All we're doing here, when we want to say what is f of 2, is we are replacing all of the x's in the function with the number 2. So f of 2 is equal to 2 times 2 plus 3 equals 7. 7 is therefore our y value. So the point at x equals 2, y equals 7 lies on the graph of this function. The same goes if we want to see what's happening at x equals negative 4. We're inputting the value of negative 4 wherever x would occur in that function to come out with negative 5, which is our y coordinate. And we can again say that the point that lies on this graph when x is equal to 4 is at negative 4, negative 5. Quick example, we've got a new function here. If f of x is equal to 2x squared, take 3x, find the value of f of 5. So first of all, we're basically just going to rewrite that function, but we're putting a 5 wherever an x appears. So 2 times y, 5 squared, take 3 times 5. Notice I've put them in brackets. That's just a really easy way of sort of keeping the place, so you know that that is where you've replaced an x. Then we've got 5 squared is 25. So we have 2 times 25 is 50. Take away 3 times 5, which is 15, equals 35. So we know that on the graph of this function, we have a point that the function passes through, which is x equals 5, y equals 35. Find the value of f of negative 4. Simply, we just go the same process. 2 times y, negative 4 squared. Take away 3 times negative 4. Noticing that the negative 4 is just going in where the x's were. We have 16 times 2 is 32. Take away negative 12. So we have 32 plus 12, which gives us 44. Therefore, we know that when x is equal to negative 4, y is equal to 44, which gives us a point on the graph at negative 4 and 44. If we wanted to, we could actually graph this and show 2 points where the function goes through without actually drawing the full curve, but we're going to avoid that for now. Just going to look at one more example, and this is more of an algebraic way that we're looking at it. So what we want to do first is see what is f of negative x. So f of negative x, once again, we are just replacing the x's with whatever is in these brackets here. So we're going to have 5 take negative x, take negative x squared, which is equal to 5, plus x, take away x, negative x squared, which would be x squared. So we are taking away x squared. we can't reduce it anymore. So that is what we've got. So our function of negative x is 5 plus x take x squared. Kind of similar to what we had in our example, in our original function, but you can see that the sign has changed for our x here. Hasn't actually changed anything about the x squared. Looking at part B, we've got f of x plus 2. So this is going to be a little bit more funky. So we're going to say f of x plus 2 is equal to 5, take away x plus 2, take away x plus 2 squared. Now, straight away, we've got ourselves into a bit of expansion that's going to need to happen. So, move that across. Function is equal to 5, take away x, take away 2. And then we're going to have to use our FOIL for this one. Take away x squared plus 2x plus 2x plus 4 gives us, we find all of our x squared coordinates, x squared terms. We have negative x squared. Now all of our x coefficients, we have 4x, which is being taken away, and another x being taken away, so we have take away 5x, and then our integer values or numbers, we've got 5 take 2 take 4. So 5 take away 6, which is negative 1. So hopefully that gives you a bit of a primer on how to use function notation and how to find the function of a different value of x.